All right. So, yeah, this workshop is on software multitasking. What the heck is that? Well, I'm sharing my screen now if you guys can see it.
Yes.
Awesome. So, like I said, this workshop is going to be on software multitasking. We're going to talk about it. It's a cool thing that you can do in programs that makes it faster and all kinds of other stuff. Before we get too far into this, I am Thomas. I'm just a nerd who likes to hang out here. I like programming, and this is just one of the fun things you can do with coding. Now, I guess I could do this. We're going to do this in an interesting order. I'm going to show a slide or two, and then I'm going to show you guys an example of software multitasking before we get too far into it. But yeah, so we got this. This is the first slide. It's incredible. Cool. So, what is this workshop? This workshop is going to teach you about software multitasking. The point is for you guys to understand how your code actually gets run on your computer. Because it's not just as simple as, hit the run button and then that's it. There's an order to these things. Understanding that order helps us take advantage of the computer. We can utilize the processor to make our programs run faster. And that's really cool because when our programs run faster, we end up with these blazing fast, super responsive, and efficient applications. When you get into the professional world, this is the kind of stuff that they want. They don't want you to write code that breaks. They don't want you to write code that lags. They want you to be using the latest cutting edge, sexiest code you could possibly write. And part of that is, without a doubt, multitasking. You will encounter that. And in addition to that, we'll understand why apps freeze or hang or stop responding. It's actually tied directly with multitasking. So, yeah. Something I do want to point out is this workshop is only going to cover the concepts. We're not going to go over any code because multitasking is a kind of a big topic, and each language has its own way of going about multitasking. So, I'm experienced with C#. If I was to show you guys the C# way, you'd look at that and, start crying blood. So freaky. And C# or C++, Python, Java, they're all going to do it different. But the concepts are all the same. So I'm going to check the next slide. Oh yeah, I guess we can cover this one, and then I'll actually show you guys the example. So when we hear the term freezing or hanging or stop responding, these are all terms you're going to hear. You've probably been playing a game one time or doing something and it says, oh, stop responding. That is, the technical way of saying that is that the threads for the program are blocked. That may not make sense right now, but by the end of this workshop, you're going to have a keen idea of what that means. Basically, a blocked thread is, in a simple term, imagine if you were going to go and cook something in the microwave. You were going to heat up some pizza from last night, and you're going to heat it up for 2 minutes, right? You also want to grab a cup of milk. Well, so you're going to eat it with your pizza. Well, a blocked thread is like if you put it in the microwave and then you just stood there and waited and waited and waited and waited for the pizza to finish cooking. And then once it was finished cooking, you'll stop waiting, take the pizza out of the microwave, and then go get your milk. During the time that you're waiting, you're stalling. And that's like a blocked thread. The thread is focused on executing some code, and it's just waiting and waiting and waiting. It can't do anything else, so it gets blocked. And this is another example of multitasking. We would use multitasking to split up the task into different parts. So using the previous example, you'd put the pizza in there for 1.5 minutes or 2 minutes, hit the start button, and then you go walk over and fill up your milk. There's no need to wait until the process is done. We can go do something else. So yeah, that is essentially why programs freeze, and this is one of the major reasons why we use multitasking. I am going to click this and exit out of this PowerPoint for just a moment to show you guys a couple examples. So this example that I'm about to show you is just a super quick C# example of multitasking in action. Don't worry about the code, it's just this window that matters. When I hit this button, the program is going to say, hey, code, I want you to wait for 5 seconds, like if we were to wait at the microwave. It's going to cause all the code to pause, like literally just stop in its tracks. And it's going to wait for 5 seconds. Watch what happens when I do that. So I click the button, and you can notice my cursor's frozen, and I can't drag the window around. Everything's frozen. And now, after 5 seconds, it says I was frozen. Let me hit that again. I'm going to try to resize it. I can't. I can't do anything. It's totally frozen. Well, I can't even bring it back up. There it goes.
My blood pressure's going up.
Yeah, we've all been there. Absolutely. Oh my gosh, that's the best. And then when it freezes too long, and then it crashes, and you lost like your whole essay you were working on or something like that. Oh my gosh, it's the
stop
best.
there. Stop.
Yes,
No.
I know. Yep. So this is why we use multitasking. Now I'm going to run the exact same code. It's literally the same code on this button. The difference is I'm using multitasking. So check this out. Push the button. It still works. I can still move it around. I can resize. I can go down and bring it back up. You can see everything still works. Like I said, this is also freezing the program for 5 seconds. The difference is it's using multitasking. So it says, oh, the microwave is running. Let me go and make sure that the UI still gets displayed right. Let me make sure I can still resize. And then once it's done being frozen, then it'll say, oh, hey, we're done being frozen. Let's go and show that pop-up. So that is an example of using it and not using it. Does anybody have any questions about that before I keep going?
So you're using this in C#, right?
This is C#, yeah.
Yeah, so what, kind of redundant, or not redundant, but it doesn't really matter if you answer it or not. What would the code that you use to freeze the program, are you doing kind of like an endless loop kind of thing?
So that is one way of doing it. Usually the major languages have some code. This will look a little weird, but basically they have something like this. Thread.sleep or pause. Pause, I think I've seen that in Python somewhere. I can't remember, but it's usually something pause or sleep or hold, a term like that indicates that we're actually stopping the execution of code.
Gotcha. So in C#,
yeah.
there's literally code that says thread dot,
Mm-hmm.
and then there are methods. So the methods here, these are part of the actual functionality of multithreading.
Yes.
Like freeze, thread, button, click. That's pre-coded. You're just kind of adding additional functionality when that happens, right? This is the UI.
You got it.
Gotcha. That's cool.
Yep. Super cool. Does anybody else have any questions or keep going? I guess I'll just wait a couple seconds. No questions. Okay. So this was an example that was just for the purpose of our workshop. Here is a real example of a program I made that used multitasking. We've all played games before. We've played games with mods before. This is a mod manager for some video game. If you're ever serious about making a program, you need to have updating possible for the program, because when you have a bug, how are you going to release the bug fix? You're going to expect your entire user base to re-download the code? Hell no. So you get updating built in. For this app, if I click this button, it automatically checks for updates. Now, you didn't notice it because everything happened immediately, but it actually just used multitasking. So a whole separate part of the program got created specifically for checking for updates. You didn't notice it, but it happened. And that prevented my app from freezing, slowing down, or whatever. It kept it nice and pretty. In this scenario, it checked the internet and confirmed. No updates? Cool. It did that pretty much instantly, so you guys didn't notice it. But what happens if my internet connection is bad? It could take 30 seconds to check. That's when you would want to use multitasking. Prevent your program from crashing in the event something takes a long time. But yeah, those are two examples for multitasking. I'm hoping that makes things make a little more sense as we get into this. Cool, so we're back into the PowerPoint. And here is a scenario. You want to watch some funny cat videos on YouTube because they're possum. Because puns are hilarious. And I'm horrible. No, so how do you do this? Well, I mean, we're not idiots. You open up the internet browser, you know? That's actually where the workshop begins. Everything with multitasking starts there. When you open an application, a lot of things happen at one time. I'm going to start with this part here. This is an extreme simplification, and I omitted a lot of stuff so we could keep this relevant to our workshop. But the operating system, Windows or Linux or Mac or your phones, even like the smartwatches, whatever, it does a bunch of things at once when you double-click on an exe, for example. The first thing is a container, a special container called a process gets created. The process holds all the info for our currently running program, the one that we double-clicked on. The system is going to give some resources to it, like the RAM. It's going to reserve however much RAM it needs in order to do this. After doing all that, it's going to create a thread, sometimes called a thread of execution. This thread is what actually runs the code. It is at this point that the application begins running the code. So when you guys work on your homework assignments, your C++ homework assignments, this is essentially what happens at an extremely high level. You click the run button so you can test to see if your assignment's actually working, and the program automatically, or Windows, automatically creates a process, assigns some RAM for it, gives it a thread, and then that thread begins running your Hello World code. Understanding how this works is how we're able to take advantage of the computer. I mentioned in the last thread what happens when you open an application. I just want to specify what an application is. An application is a program stored somewhere on your computer or device, whatever it is. Whether it's on like a hard disk or some flash memory like a USB. It's a static entity. By definition, an application is a static entity, meaning it's not running. It's just the downloaded files. In scenario 1, the application would be your internet browser. For me, it's just Firefox. It's the files of Firefox, not necessarily running. When I run it, it becomes a process. I did kind of explain processes already. The short answer of what is a process, it's just a program running on your computer. It's Firefox. It tracks some special info and the stuff like your variables and what's going on right now. Like if you're in a loop, it would track like what number of loops you've done so far. That's the simple answer. The long answer, which is the technical answer, a process is a container that the application, how do I write this? A container for the application executing on the computer. It holds all the resources. Every application on your computer has its own, every running application has its own process. Interestingly, if I ran Firefox twice, it's two separate processes. Just because it's the same exe does not mean it's the same process. A process is for one thing at a time, each application that gets run. And this is actually how you're able to have two browsers open at the same time, and they're not like mixed up who's who, because they're different processes. And I said this earlier, the process also holds all the information about the program and its current state. Examples are your compiled code, the reserved system resources, the state of the process, which is some complicated stuff, all the registers, the threads, your methods, variables, etc. You guys get it. I would like to show an example here real quick. Give me just a moment to let this finish running. Cool. So, where is it? Okay, perfect. Here's the task manager. We've all seen it before. Now that we've talked about processes, this might make a little more sense. I have the processes tab opened in my task manager. You can see all of the processes that are running on my computer. I can drop it down and you can see, I think these may be threads, I'm not 100% sure, or sub-processes. Regardless, you can see the processes that the operating system is managing. if you click on the Performance tab, you can actually see how many threads are running on your computer at any given time. It's very interesting. Here we can see all the processes. But yeah, so that kind of hopefully puts into perspective what exactly processes and threads are. This is a more elaborate explanation of threading, or I'm sorry, threads. It's just a part of the process that runs the code. We've already gone over that a couple times. The technical answer that your teacher would want to see on the test is it's the smallest sequence of instructions that can be managed by the operating system. It is a component of the process. It's just a part. It's also, like I've said a couple times now, it's used to actually execute the application's code, and it uses the resources that the process shares. I may have said this in the process section, I don't know. Oh yeah, I did. The process holds all the information about the program and its current state. Every thread in your process shares those resources. So when I start Firefox and have 10 threads opened, all 10 threads share the resources from my one Firefox process. This is an important part here. The process will focus entirely on executing the code. This goes back to why our program freezes. If it takes longer than about 100 milliseconds, give or take, the program will start to freeze because it can't do anything else. And it'll stop responding until it's able to execute further code. This is examples of where we would do multitasking. Get another thread in there. And an interesting side note is threads were actually invented a long time ago. The idea of them was so you could do more than one thing at a time without having to copy all the resources in the process. Also, it's really resource intensive, swapping between processes. So it's easy to swap between threads. They don't have anything other than some code. But yeah, that's that. We'll put it all together. We got scenario 1. You started your internet browser to watch those funny cat videos. The operating system makes the process, allocates the resources, and creates one or more threads for the browser. This will make it so it can start up fast and run all the code it needs to run in an optimized time. Makes it feel like your browser is this lightning fast, modern, sleek thing. And when it's finished initializing, it'll continue running the code until the program is closed and the process exits. Yeah. At this point, does anybody have any questions? I did do a little bit of word vomit. My apologies.
So this kind of helps when a program kind of goes into kind of sleep mode, right? And sits in your taskbar. That you kind of need to have multi-threading happening to get that to work, right?
Yeah.
Also, when you, in your experience coding programs that use this, is this as simple as kind of calling this into whatever compiler and saying, hey, I want multi-threading? Or do you need, like, in every method say, hey, if this lags, then I don't know, task dot, do, go to other thread or whatever, do you specifically have to call that out to use multi-threading in every single kind of function method? Or is this, how does this normally look in your workflow?
That is a really good question. I think that the best answer is it depends on the language. I use C#, and in C#, it's as easy. It actually does it for you automatically. I'll pull up the code really quick. I think this is the multitasking demo.
This is a great opportunity, by the way, because I know for like the past year you've been trying to convert people to C#.
C# rules!
Your corner of
the world
of nerdom.
Yes.
I think it's pronounced C hashtag.
Leo, you can mute yourself again.
Don't speak those devil words around me.
We did not allow you to speak, Leo.
Yeah,
All
but to answer your question, like I said, our first two buttons, this was the one that froze, this is the one that doesn't freeze. It's the same code, but in C#, this is one way of having multitasking. This code right here. Sorry, my throat's weird. Now, this is just one of the ways to do it, and this is one of the ways to set it up. There's multiple ways to even use this. It just depends on how you want to. But the point is, with just this little code right here, built into C#, there's no extra work. It will automatically manage all the threads and do all the multitasking for you, so that when I want this code to run, it will not freeze, and it'll run in the most optimized way possible.
That's pretty cool.
Absolutely, I love it.
You kind of wonder why that's not by default, like, a thing, you know, like, what, why is it necessary to call that function? If it's, I don't know, does this make sense? That it's not something that's already kind of by default when you run a program, when you compile your program, that it looks for the most optimal way to run it. Sure,
it makes sense for it to do that, but one of the things about programming, and we all can attest to this as coders, we need control. C++ is all about control. As an example, if the program by default did multitasking, it would be easier, but now we're no longer in control. We don't know how that's working. Also, as we'll get to later, there are actually some issues with multitasking that you have to be mindful of. It does consume resources. You could run into actual bugs. Yeah, so also it's not always necessary. So I think that they leave it up to the developer. As an interesting side note, your computer by default does use multitasking. I think it's been like this for decades. It uses multitasking to share your processor. A processor's only so big. What about a single core processor? That was like, what, 2005? 2002? Which isn't that long ago. We had only single core processors. How the hell did we run all of Windows XP and sometimes even Windows Vista on a single processor? Multitasking. And we'll actually go over which type it was later. But yeah, that's just a side note. That, well, Visual Studio may not do it by default. Our operating system does. Awesome. Does anybody else have any other questions? I'll just wait a couple seconds. No questions. All right, we will keep going. Now the big question, where does multitasking actually come in? Well, multitasking, like I've said a few times now, is the act of doing more than one thing at a time. It's also known as concurrency. I want to point something out here. From this point on, terms are going to get weird because each language has their own words. Sometimes they'll call A B and then they'll call B A. So the principles we're talking about is what you need to remember. But some languages have a different word for it. So this is just something to keep in mind. But essentially, there's this thing called multitasking, which is the act of doing more than one thing at a time. In the case of our process, we are running more than one thread at a time. Like I said way back, the thread is what actually runs our code. So we have more than one brain running our code at a time. And when we do this, we can split our code up into pieces. So powerful brains are working on smaller problems at the same time, gets it done faster. So you could use multiple threads, or you can just make sure your code never stalls or waits by managing your time properly. Going back to the microwave example, we don't have to stand there and wait. We can go and get our cup of milk while our microwave is running. That's managing our time, keeping our program running blazing fast. As I said earlier, it's used to make your apps faster, more responsive, and resistant to freezing. There are two main types of multitasking. There are others that are more advanced and not necessary. The two main types are asynchronous programming and multithreading, or parallelism, or parallel programming. You might have heard of multithreading. We're going to go into both of those right now. Asynchronous programming, my personal favorite because it's really cool. We still have one thread. I mean, maybe you have more, but essentially a single thread continues to run one set of instructions, like we did with the microwave. We continue to run one set of instructions. However, while we're waiting for our food in the microwave to finish, we're going to stop waiting for food and we're going to go do whatever the hell else we want to do. We're going to pause our current execution to do some other stuff. In this example, you can see this lady here, she's using the washing machine for her clothes, and instead of just standing there waiting like an idiot for her washing machine to finish, she paused that, she paused that, and is now reading a book.
I'm kind of curious what you Googled to find this picture.
I Googled cartoon washing machine. Yeah, I got lucky on that one. So, this is a really good example. We don't need, I don't need to ask Eric. I don't need to say, hey, Eric, can you wash my clothes for me and stand there and wait for it to finish?
Absolutely not.
Yeah, fuck that, Yeah, I can do this on my own. I can just manage my time better, giving the appearance of a blazing fast program, even though it's not multi-threaded. Another example is having your app, and this is a real-world example. Your app needs to load a database from file, like all the users connected to your website. Let's say you have hundreds of thousands of users. It's going to take a second to load all that. And maybe the hardware's bad. It'll take a while to load all that, So periodically the program's going to stop loading data so it can do stuff like update the user interface and the button clicking. Like in my example I showed earlier, that was asynchronous programming. I was not using more than one thread. All I did was I froze for 5 seconds, but I said, hey, even though it's frozen, go do other stuff, like make sure the window can still resize and move around. Does that make sense? Anyone? Questions?
No, that makes sense.
Cool. Yeah, asynchronous programming is my favorite because it's more of a challenge. You're really having to think about optimizing your code. Sure, you could just throw another thread in there. I'll just pay Eric to do slave labor and wait there for it to be done. That's easy. But it sounds a lot cooler to really write an efficient, well-optimized program that can manage its time better. And if you wanted the best of both worlds, write an optimized asynchronous program that's also using multithreading. Dude, you're going to get like $120 an hour for being such a boss. Cool. Let's talk about the second form, which is multithreading. This is a lot of words, my bad. Multithreading is also known as parallelism or parallel programming. You're using more than one thread for your process. Each thread is running its own set of instructions, its own code basically, independent from the other threads, but also simultaneously. Your processor has multiple cores built into it. When you use multithreading, you're using more than one part of the processor to solve the problem. And in this picture over here on the right, you can see, we got a team of like IT scammers, trying to get credit card info. You have a team of people here. It looks like they're pretty much all working on code. It looks like Visual Studio down there. And with this, you've got multiple brains working on the same problem. And this is really efficient. Let's pretend that they're all working on a Microsoft document, like, I don't know, it's just anything, a document. They're all sharing the same file. Even though they're sharing the same file, they're working independently. This person here is focused on one thing, while that person there is focused on a totally different thing. All of their focus is on their current task. That's how multiple threads work. Shares the same document, but it's focused on something different. Cool. So, and now in our second example, AI pathfinding. Definitely when you want to use multitasking. Let's say you had a scene with 100 enemies or more in this one little scene. The enemies are trying to chase the player, which is pathfinding. Instead of trying to calculate all those paths on every single frame, while also trying to keep the player's experience smooth, just use 5 separate threads to calculate the pathfinding. So you're going to split it up. So 20 enemies are going to get calculated per extra 5 threads. So we're calculating 5 paths at once. That's great. That's great performance. All while we're not affecting the player, or any other part of the program. It's just 5 threads over there doing their own thing, and that's how you'd make it super efficient. Anybody have questions about that part?
Nope.
Awesome. When should you use multitasking? Here's some examples. Whenever you access stuff from the disk, the best practice is to always use multitasking, because there's a chance it will take a long time. It may not, but there's a chance. Also, let's say I was looking for every file on my computer that started with the letter A. That's going to take a while. Multitasking. Whenever you contact a website's API, let's say we were making an app to mess with Google. Use multitasking. Because it's going over the internet, we have to wait for a response. When we're doing complex math calculations, we could split it up into 10 problems, solve it on a different thread, or manage our time per problem. Pathfinding. When you do a loop, Eric mentioned this earlier. If you have a loop that runs for a long time, or could run for a long time, make it multitasked. Because even though it might not be running a long time now while you're making it, if it's possible, make it multitasking so it doesn't freeze your app. A lot of times when an app is frozen and you get pissed off, they didn't make it that way. They just didn't plan for what you're doing. And that's why it froze. And, you know, when you want to have a lot of threads working on one problem, you want to make your app fast because that's cool. Or because, why not? Multitasking is fun. Something that's very important, and we're going to cover this pretty soon. If you want to make your app fast, multitasking isn't necessarily the answer. Maybe it's just bad code. So that's a very important thing to keep in mind. If you want to make your app fast, make sure it's not, like, let me rephrase this. If your app is slow, make sure it's not just that it needs to be refactored. Now, when should, or which form should you use, kind of thing. I say it depends on the situation. Run through these checks. Ask yourself if you really need it, or why you need it. If it's just because your app is slow, like I said, make sure you don't have bad code. Refactor it first. If you do want it, which could be just because, why not? Ask yourself if you want multiple brains solving one problem, like we had with the this example here. Or if you want one brain that's just really good at managing its time. Something I may have forgot to mention earlier. An issue with, well, I might mention it later, I don't know. Basically, one issue with multi-threading, using more than one thread, is it does cost resources to create, manage, and delete each thread. As developers trying to be worth something, we don't want to be wasteful with resources. So I do consider it important to be mindful of whether or not we use multiple brains. Multiple brains does cost more. Is your problem worth the cost? I'm not saying it's so bad it's going to like break everything. No, you'll probably not even notice it. But the fact is it does consume more resources. And if you're careless about how you code it, it might actually be a problem. You might waste tons of resources and freeze the program because, like, creating a thread in an infinite loop, you know, it's no go. You could crash your whole PC with that. But yeah, so that's basically when you pick. Do you really need it? And if so, do you want more than one brain, or you just want to manage your time better? If you want more than one brain, multi-threading. If you want to manage your time better, asynchronous programming. There are some dangers or risks. Like we've said before, this is just splitting up your work into multiple parts. It does have great performance benefits, but some issues like race conditions. A race condition is when you have multiple, we'll just say multi-threading for now because that's more obvious. Let's say we have more than one thread running at the same time. I'm waiting for the result of both threads. And then I'm going to continue. Depending on how you code that, you might accidentally introduce a race condition, which means whichever one finishes first is the winner. That can happen. It can screw everything up. And it depends on who knows what. That could be anything. And the second time you run the program, the loser might actually win this time. Race conditions are bad, So you want to make sure that when you write multi-threaded code or multitasking code, that your program is waiting the way it needs to until all the data is in before we continue. In C#, they pretty much do that for you. C# comes with so many tools. Race conditions are kind of difficult to get yourself into. So in C#, these issues aren't as common. But in other languages, or if you're trying to manage each thread manually, which is difficult, you might run into a race condition or a deadlock. Thread A is waiting for thread B, and thread B is waiting for thread A. No one can continue because they both are waiting for one guy to finish, so they get deadlocked. This causes nothing to happen. It's no good. Again, this might be an issue if you're not managing your threads well. Eric asked me a question not too long ago. Are there libraries that you can download from the internet to do multi-threading? Yeah, probably, depending on your language. I would look into that before trying to manage threads yourself. Or make a stupid program that you don't mind losing and try to manage threads with that and figure out how to do it. I don't recommend using multitasking in an app that you're serious about because there is a good chance you could bust things up. The last thing that I've encountered, I don't know the technical term for it, is when thread A has some resources that, I think I wrote this poorly. Basically, thread A is trying to use some resources from thread B. The problem is those resources are created and managed by thread B. Thread A can't use them. That'd be like if I was saying, going to Eric's house and say, give me your stuff. He's like, what? You can't just, you gotta ask me, dude. You know, so as an example, you have to use this thing called marshalling. Basically, you gotta ask thread B and say, hey, can I borrow that variable? I need that variable real quick. Otherwise, you can't because it's in a different container. But yeah, this one's actually a pretty common issue to run into. Just something to be mindful of. It's pretty simple to fix, depending on your language. And that is actually the last slide. Anybody have any questions?
No, that was pretty good info. Thank you.
Mm-hmm.
I kind of wonder, like, languages like Python that are super high level.
Yeah.
How much of this is kind of a part of that standard library? I would think that, especially Python, has something in there that kind of does what C# did in your example, you know? Because of just the nature of what Python is. It's just an interpreted language that I don't know, just runs at a top layer in computer. So
yeah.
TJ, we need to take notes on this. Let's find that out for next week.
Yes, sir. I am.
Yes, sir.
Nice.
Yeah, this was pretty cool. Thanks, man. Thanks
No worries.
for taking the time to learn this.
Yeah, it's super fun, and it is absolutely necessary in some situations. You cannot get away with not doing this sometimes.
Have you faced I'm assuming that you kind of got into this multi-threading and all that. The way you kind of discovered this. I mean, I'm pretty sure any good programmer at some point has discovered this and eventually had to learn how to do multi-threading and deal with it. But for you, when you started programming, did you kind of like encounter a problem with a program where it was just kind of like freezing and you're like, how do I solve this? And you kind of bumped into multi-threading?
Yep. So something that you guys will probably use more often than you'd expect is zip files. You'll use them in your code, or in your program, I should say. It's very efficient to store data in a zip file and then unzip it into memory. Rather than somewhere on your computer, you'll unzip it into RAM. It makes it so you can compress all the data you need and access it super efficiently without taking up resources. You'd be surprised, it actually takes a decent amount of time to go through a zip file that's not too big. I mean, like 100 items, that is kind of big, but when you're doing it for a program, chances are there's like thousands of items in the zip file. That's going to freeze your program. So, because it has to iterate through each and every one. So yeah, I wouldn't worry about multitasking unless you guys just thought it'd be like, cool because it is. But yeah, you're going to run into it at some point, and that's really when you'd learn it. It's just like, why is this frozen? I'm mad now.
I kind of wonder how, like in C and C++, there's probably something in there from
Oh,
the
yeah.
library that deals with this, but it's probably a lot more complicated in the sense that
Mm,
there's so much more control that you have with C++ dealing with
yeah.
the memory. You know, you'll probably, if you
True.
do that, what you just said, load a zip file into RAM, then you
True.
probably have to find a way to unload it from RAM in C++ because it's not going to do it automatically because it doesn't really have garbage collection like Python and C# does, right?
Interesting. Yeah, that's a good point. I am curious about that as well. It would be interesting to do multi-threading or some form of multitasking in C++.
You just got into C++, right?
Yeah, starting to mess around
Ooh,
with it.
there you go. Well,
Yeah, I'm just trying to think of a good app. I genuinely think the best way to learn a programming language is to say, hey, what's a cool program I want to make in this language? And then do it. You're going to encounter real problems trying to solve this thing yourself. Yeah, super fun.
an astrology app.
Oh, no.
Every
Oh,
day
no.
you get your reading, pulls from an API. I'm telling you what makes money, Thomas. The
Yeah.
Midwest, every girl's into this.
I'll make the app and yeah. Does anybody have any other questions? I want to make sure everyone has a chance to ask. It's a friendly environment. I won't bite unless you like Java. Then I will bite. No, I'm just kidding.
I love Java.
Yeah, it's weird how so many people dislike Java, even though it's just like C#. Like I'll never understand that. Yeah. No questions. It looks like everyone's good.
All right. Well, I actually have to go across the street and go to my next meeting. But that was pretty cool. Thanks, dude. That was a lot of good information. Gets me to think a lot about like what I've coded before and how I could have. I haven't really needed to do multi-threading yet, but how I could have maybe made certain parts of it better that would have made sense to kind of future-proof that program so that if it ever gets pushed to its limits, then it would know how to handle that. And it kind of makes me wonder, like, especially with like website stuff, me and CJ are kind of doing some Python stuff pretty soon, and me and Nero are doing some Django stuff. Then, like, you know, how much of this plays into running a website? Do we need to learn this? You know, it's kind of interesting to think about that. Something I haven't really thought about before. So
yeah, if you're trying to contact your website, like the back end, you're gonna have to use multitasking. I mean, you don't have to, but if you're trying to do what the business world uses, don't freeze your program. But yeah, this was fun. Thank you guys for showing up. If you have any questions later on, just let me know, and this will get uploaded on YouTube at some point in the near future.
Right on. Well,
cool.
I do see a new face here, Kenta. Hi. Sorry that I don't have too much time to kind of like chat and get to know you a bit, but maybe you'll show up at the next workshop and maybe we can chat it up and see what, you know, who you are, how you're doing and all that. But
nice.
All right, I'm gonna head out and go meet the next people that I need to meet.
Cool.
All right, see you guys.
Thanks everyone for coming.